All right, so I wanted to review just a little bit about inverse trig functions on this first video, just inverse trig in general. It may have been a while since you've seen this in Honors Pre-Calc last year. The notation for inverse trig, our textbook and on the AP exam a lot does use this arcsine, arccosine, arctangent, but you might also be familiar with like the inverse function like that, like or inverse cosine, inverse tangent, inverse secant. They both mean the same, and in terms of what you're looking for an angle who has that sine ratio or has that cosine ratio. The problem with trig functions, though, when you start looking at inverses, is that the trig functions are periodic. They're not one-to-one functions. There are lots of angles who have a value that's equal to 1/2 for a sine ratio, right? Like one of them is 30 degrees or pi over 6, but the problem is that you could also have 5 pi over 6, or you could have 360 plus that 30 degrees, 390 degrees, or any time that you land on either one of these in the quadrants, those angles have a ratio of 1/2 for sine. So if I'm trying to go backwards, I want to come up with a consistent way, a uniform way to define these functions so that their inverses will in fact be 1-to-1. And so at some point, you restricted these inverse functions into certain quadrants so that there's no ambiguity, so we know exactly what ratio, what angle we are talking about when we're trying to evaluate its inverse function. And so what I have here is basically sort of like a map, if you will, of where the functions live. And everything that's positive, so if you have a positive ratio, it's easy, they all live in quadrant 1. Everything will be defined between 0 and pi over 2. But then we split. If your ratio is negative, and you are either cosine, secant, or cotangent, those negative angles, in terms of a ratio I should say, will live in quadrant 2. And so the cosine inverse, secant inverse, and cotangent inverse will have a range of angles that will run you between, let's use green, those will run you between 0 degrees and 180 degrees, or 0 to pi radians. So those three functions will have that as a possible outcome. The other three trig functions, so if you are inverse sine, inverse tangent, or inverse cosecant, and you have a negative ratio, you're going to put those down in quadrant 4. But what you have to be careful of is the way that these are defined, you want a continuous set of angles. So, I mean, clearly this would be 0 to pi over 2, but instead of having a break and being discontinuous and starting like at 270 or 3 pi over 2, you actually go back to the negative counterpart. So these angles here, I guess I could use green, these angles here will actually be defined from negative pi over 2 to positive pi over 2. And that's why you have to be very, very careful. If you have a sine ratio, tangent ratio, or cosecant ratio that's negative, you draw it in quadrant 4, you choose its negative angle. It could be negative 45 degrees, negative 60 degrees, or its radian equivalent. Even though there might be a coterminal angle that's positive, you choose the one that is defined in this restricted domain. So if I go back up to the warm-up problems and I'm looking for the arccosine of 1/2, well then there should be no ambiguity whatsoever. 1/2, its positive ratio, everything that's positive will exist in quadrant 1. And so there's my sine ratio, 1 to 2, therefore that's pi over 6. Inverse cosine is a negative ratio, no ambiguity. Cosine, when it's negative, lives in quadrant 2. Negative 1 to 2, root 3. It's a 60-degree reference angle sitting in quadrant 2. That would be 120 degrees, or 2 pi over 3. And each of these ratios have a defined place where to put them. Arctangent of 1. Tangent ratio is positive, so it's a 1-to-1 ratio. That's a 45-degree angle, or pi over 4. Arccotangent of negative root 3. Cotangent and tangent, you have to be careful because they're negative split. Arccotangent, when it's negative, is in fact in quadrant 2, where arctangent, if it's negative, would have been down in quadrant 4. And I know that's always something that the HBC students sometimes mix up. Cotangent of root 3, so we'll go ahead and draw our ratio, adjacent over opposite. Excuse me. So that's a 30-degree reference angle in quadrant 2, which is 5 pi over 6 radians. And arc cosine of 0. Cosine is 0 when the y value is 0. And even though there are 2 places, only one exists in its domain. And so that would be pi over 2 radians. And then our last one, arc sine of -1. So that's going to be down in quadrant 4 because it's negative. Oh, actually, that's wrong. That's if it were a 45-degree angle. -1 down here for sine is at 270 degrees, but the one that fits the restricted range would be negative pi over 2. And so I've already seen, Jeremy, you can catch my typo right there. 1, 2, 3, 4, 5, 4. So that's not good. I'll fix that for next year. But in terms of like the definition of the inverse trig functions, here's where they are in terms of the restricted domains. This you should know. This is important. In honors pre-calc, I always refer to that as like the map of where the angles live. But obviously, pay attention to the negative angles in case those come up when you start evaluating your definite integrals.